Use either a table or a graph to determine the limit as x approaches 3 of x squared minus 2x minus 3 over x squared minus 5x plus 6. I'm thinking AP pre-calculus thoughts. Now that AP pre-calculus exists, we dealt a lot with holes and asymptotes and zeros and stuff like that. So what I'm going to do is I'm going to factor the numerator, I'm going to factor the denominator, and I'm going to see what I get. Two numbers that add up to -2 and multiply out to -3 are going to be x minus 3, x plus 1. Two numbers that multiply out to -5, add up to -5 and multiply out to 6 are going to be x minus 3, x minus 2. Now, this is what we have. What we have is a whole at x equals 3. We have a 0 at x equals -1, and we have a vertical asymptote at x equals 2. We also know that since the leading coefficient up here is x squared and the leading coefficient is x squared, that we're going to have a horizontal asymptote at x squared over x squared, which is 1. So what I could do is I can make a little rough sketch of this. Okay, if I knew how to draw a nice straight line, this would be a whole lot better. But this is basically, you get what you pay for, and you pay absolutely nothing for my services. So if the horizontal asymptote is 1, that means things are going to level out right here. Okay, this has a 0 at, where was my 0? At -1, so I have a 0 at -1. Okay, a vertical asymptote at 2, so we'll put a vertical asymptote here. And since everything kind of levels out here at +1, we are going to get a picture that looks like this. Like that, and then like that. Now, somewhere over here at 3, I'm going to get my hole. So there's 3. Now, there's my graph. There's my graph. So using this graph, I can kind of come up with a nice little estimate of what this would be. But you know what? I don't want to do that. I don't want to use just my graph. I'm actually going to use the fact, since these guys are this, they cancel out. And so that leaves me with the limit as x approaches 3 of x plus 1 over x minus 2. Plug in 3 plus 1 over 3 minus 2, and that gets me 4 over 1. So my limit's going to be 4, and I can kind of see that. Now, granted, my picture is absolutely not perfect by any stretch of the imagination, but using the picture that I made, I can kind of look at this and say, oh yeah, I guess I can see where that old crazy math guy came up with that. So that's what I got. Have fun with it.